Gallium Arsenide Portable Instrument GM10 Introduction to Use. Lower part.
GM10 is a portable gallium arsenide portable instrument, can be held or shoulder bag, mainly used for gallium arsenide optical fiber temperature sensor temperature performance detection and troubleshooting. Next, I will introduce on-site usage instructions. 3. Introduction to on-site usage of GM10. For the convenience of explanation, in addition to the portable gallium arsenide instrument GM10, I also prepared a gallium arsenide fiber optic temperature sensor with a light mode field of 60 to 0.5 ohm. In addition, for on-site use, it is necessary to prepare 1 wiping tissue, 1 recordable pen, and 1 installation process testing record sheet. The detection is carried out into steps. First of all, the appearance of the sensor detection and use of precautions. The packaging of the sensor sent to the site is as follows. Open the packaging and take out the sensor, which is divided into 3 parts. The probe and fiber optic connector at both ends, and the fiber optic cable in the middle. Firstly, check whether the appearance of the sensor is intact, whether the label information on the sensor matches the content on the outer packaging bag, whether the dust cap is properly covered, and whether the cable body is damaged. The inspection is complete. There are 2 things to note when using. 1. The sensor fiber optic cable be prohibit tying knots, bend excessively, or pulled forcefully, especially at the connection between the connector and the probe, otherwise the internal fiber is easily broken. 2. Sensor is not connected to the equipment. It is strictly prohibited to remove the dust cap to prevent the core from being contaminated and affecting its temperature measurement performance. These precautions are also available on the outer packaging bag. The second is temperature sensor performance detection and operation methods. First, remove the GM10 optical interface dust cap. Method: press down on the dust cap, rotate it to the right to the slot position, and then remove the dust cap. Clean the optical interface. Method: clean the pen. Remove the pen cap, align the pen core vertically with the light interface, press down to clean, and repeat twice. Secondly, the dust-proof cap on the sensor is removed to clean the core cylinder and end face. Method: rub the plunger surface with a pre-prepared tissue and rotate, and wipe it twice. Then place the plunger end face on the tissue and wipe it flat twice. Then connect the sensor to the device. Method: align one side of the circumference above the fiber optic connector core with the groove on one side of the optical interface. Press down and turn left to make the outer groove of the fiber optic connector hang onto the protruding point of the optical interface, and it is successful. After the connection, adjust the interface channel brand so that it corresponds to the device brand. You can detect the temperature measurement performance of the sensor. We are TMEAS, so we have to switch to TMEAS. As can be seen, the current temperature is 20.2 degrees Celsius. The light source value is 2.6, and the interference value is 10. According to the result determination comparison value table, it can be concluded that the temperature measurement performance of the sensor is good. At this point, we need to record the measured values on the corresponding installation process test record table so that the subsequent process can judge whether the previous process operation is normal. The values that need to be recorded include sensor number referring to the value on the label of the sensor, the installation position slot number referring to the value here, the number of segments referring to the value here, and then the detection person, light source value, interference value, and temperature. Write the process on site in the same column. Assuming we are conducting incoming inspection, we should write the 15th number in the sensor number column. Write the installation position slot number as 70 slots, and the number of paragraphs is 34. In the incoming material record column, the inspector writes, for example, Shangsan, light source value just measured, 2.6, interference value, 10. The temperature is 20.2, then the value of the incoming material detection process is recorded. A final note, why has it been emphasized earlier that before the sensor is connected to the device, both the connector core and optical interface need to be cleaned? Because cleaning can solve 90% of the sensor's problems. Let me show you. Remove the sensor that has just performed well, wipe the end face of the puck on the dirty tissue with dust, and do not clean it before connecting to the device. It can be seen that the interference value of the sensor has increased from 11 just now to about 145, and the temperature measurement performance has deteriorated. Let's wipe and clean the connector core and optical interface separately. And then connect them to take a look. At this point, the interference value has decreased from 145 just now to about 12, and the temperature measurement has returned to a good state, which is enough to demonstrate the importance of cleaning. That's all for today. Thanks for watching.